Line H2, learning task number 3, determine low voltage three-phase service requirements. We've gone through single-phase service requirements in first and second year, or at least your teacher should have gone through how we make those determinations for them. Not every teacher goes through all of the modules, but we will in this course because, hey, that's the proper thing to do, and we are hitting those ITA levels. We're going to talk about permanent as well as temporary types of services that are going to be utilized on three-phase systems. A temporary service is going to be anything that is a non-permanent type of service that is utilized during construction, demolition, or experimental or testing facilities. And there's an entire Canadian Electrical Code section that is going to go and be corresponding to this, so with specialized sets of rules, etc., and that's going to go and be your section 76. Section 76 is going to go and tell us that we need to have service equipment that is going to be installed outdoors, because usually we don't have a finished building yet on site, and it's going to have to be accessible to locked or to authorized persons only, so on site and behind, some sort of barricade, capable of being locked. If you take a look at, these panels over here, you see that there is a hasp on this weatherproof panel. Protected against weather and mechanical damage. So this temporary service, we see that it is a weatherproof panel. It's got the proper fittings, the proper type of cable, etc. that's feeding into it. You can even see the drip cap over the top over here. And protected against mechanical damage by location. It's going to have to be high enough up, not right close to a driveway where it's going to get taken off by trucks, etc. And last of all, it is not to exceed 200 amps where mounted on a single pole. This doesn't mean that you're not allowed to go and have 400 amp services. You are allowed to have 400 amp temporary services. In a lot of your large scale construction, massive, high rises or things like that, it's not uncommon for your temporary service to be something along the lines of a 4 or even a 600 amp service. In those cases, because you've broken over top of the 200 amp rating, you're going to go and have to have something that's going to be supported on at least two sides. So you're still going to go and you can have a 400 amp overhead fed service, but then you're going to build the whole thing onto a large set of frames that's going to be supported off of a couple of posts, or in some cases inside of a temporary shed. Common way to go and meet all the requirements that we were talked about: accessible to authorized persons, capable of being locked and protected against weather, is to go and have them on a pole like this. What you're then able to do is you're able to go and take power from this just for the construction phase. We'll commonly see these in construction phase. Less commonly are we actually going to go and see them during demolition. But if we place them like this during the construction phase, we'll go and have receptacles down here that everybody's going to go and plug everything into. What we're not allowed to do, according to 76014, is we are not allowed to go and take an actual cable from this. Now, you see it happen all the time, but it is illegal. It would be illegal to go and take a Lumix from here, or even, a proper cable, like a tech cable for direct underground burial, and to run this thing all the way over to the house, and then to go and backfeed anything. And we see this happen in industry. If you've been around housing at all, you'll have seen these where somebody is going to run in a backfeed to the house panel, and then they'll just heat up the panel so that they can go and distribute out a bunch of plugs, the kitchen counter receptacles and the bathroom receptacles, so that they have got some stuff inside of the house. It's actually highly illegal, because everybody that's inside of the house should be working off the temporary power, and if for whatever reason hydro came and connected to the main power while you still have this backfeed inside there, you're going to go and end up with a line-to-line fault that's going to be there when they go to close in. So we're just not allowed to go and do that. We do have a bunch of other sections that are also going to go and cover temporary services. Section 76, like we said, is going to be the main one, but we're also still going to have to go and utilize some of the main sections of our code. Section 6, which is going to talk about spans, this overhead span, how high it has to be over top of roads, maximum spans, etc. Locations, grounding and bonding, which is going to be your section 10. High voltage, if it is going to go and be a high voltage type of installation. Off of there, motor loads, if you're going to have permanently connected motor loads in some large scale construction, particularly in low-lying areas, you're going to have permanent, pumps that are going to be set up where they're digging down for foundations and footings and stuff like that as well. So proper section of the code, you got to still follow them where applicable, and then 76 just tells us about the actual service itself, and everything else that we wire out of it will follow the applicable sections of code. For our other ones that we have to go and look at here, we've got to talk about permanent low voltage three-phase services, so under 750 volts. This is just going to be our regular three-phase services. Identification is going to be covered by the Canadian Electrical Code. Section 4 tells us that we have to have our three lines being phase A, which is going to be red, phase B, which is going to be black, and phase C, that is going to go and be blue. If you go to section 24 as well, you'll find out that there is, bonus, a second three-phase colors inside of that section 24. Section 24 is to do with my systems inside of a hospital. So where I've got an isolated system, it's a particular type of system that you have to have it isolated from regulars, so that if there's people on heart machines and stuff like that, that's not going to go and screw them over if there's any transients on it. So they create these specialized isolated systems, and so they have this other system that is going to be composed of three different colors. I'm not going to tell you which one it is, because then you never go and look this stuff up yourself, but I'll test you on it later on to find out if you did. 4026 is going to be a rule that you need to be familiar with as well, because it's going to start talking about differentiations between sizes of cables that we are going to go and have. Let me just go and erase this one over here. 1 second. Just cut that and erase these. When we have got cables that are going to be feeding into our system, depending upon the size or the ampacity, we're not always going to be able to go and find red, black, and blue cables that we are going to be able to pull through. They are available through a lot of our sizes, but once we get into larger sizes, particularly into the aughts, where we're going into, the 1/0, 2/0, etc., it's very common that we are only going to go and have thick black cables, and we're going to have to pull these all in, and then what we have to do is we have to go and do what's called phase identification. If the conductors are larger than number 2, in other words, if they are a number 1 or larger, then what we have to do is we have to go and identify the last 6 inches, and commonly we're going to go and do this through what we refer to as being our phasing tape, where we're going to stick a wrap around the red, we're going to stick a couple wraps around the blue. You need to identify at least a good 6 inches of continuous wrap. It should not just be one strip laid lengthwise along there that's going to go and fall off. You're going to have to go and identify them like that, as well as you're going to have to go and identify your neutral the same way with some white tape. I know it's gray over here, but it's the closest I got to white for markers. You're going to do this inside of all of your cables. Usually you identify them before you go and pull them in. However, in some cases, people will pull them in and then they're just going to go and meter them out later on to figure out which phase is which at the other end. 4028 does go and have a bit of an issue, and that's when we deal with mineral insulated cable, which we do have in some of our mines in particular, where we have a lot of three-phase services, and sometimes they're just going to be low voltage services coming into some of these sections where you got a massive mine. It's not uncommon for these things to go and have a couple of different services around the property, because they can be scattered over a couple of hundreds of acres. MI cable is just going to be a continuous copper sheath, and then inside of that it's going to go and have a whole pile of powdered mineral. That's where it gets the name, and then it's got bare conductors inside. But when you terminate them, you are going to go and place colored sleeves that are going to go over top of them. Because of its construction, it does get a pass on this rule, the 4026 that we were talking about, where we have to phase identify everything, that it's going to be larger than number 1. Anything smaller than number 1, so number 2 and downward, has to be an actual continuous color, other than the MI cable. 6308 is another one that's a bit of an oddball that we're going to go and see in services sometimes, and that's where it states that we're allowed to have a bare neutral for our conductors. And it's only allowed when A, it is made of copper and it is run inside of a raceway. So you have to have it in a raceway where it's not going to have dissimilar metal or galvanic contacts. So really it's just going to be inside of PVC or DB2 that you would have to have that. Or if it's made of aluminum and it's run above ground in a non-metallic or an aluminum raceway, so then you're not going to once again have that galvanic reaction. Or we're allowed to have a bare neutral as part of a busway or a service entrance cable. Some types of service entrance cable actually have a bare neutral that's going to be concentrically wrapped around it. Our ERD, underground residential distribution cable, you hear more about that in fourth year, is a very common one that has got a bare wrap of copper that's going to be the neutral. Last of all, it can also be part of a neutral supported cable that we're using for overhead distribution, part of 6302 subrule 2. And the very last section inside of this learning task over here talks about a rule that we have, or about a concept that we've talked about a ton, which is going to be our high delta. And we've talked about this a number of times, 4-wire delta, where we have that one center tapped winding that's between the B and C. The high leg has to be A. The panel board has to keep A away from the B and C so that we don't accidentally stick a high value of voltage across to our neutral. And we have to just keep that high leg separated across these. But we've gone over that so many times at this point, I'm going to go and skip over that because you should be fully aware, fully fluent with these concepts. All right, that's it for this learning task here. We are through the H2 section. We've just got one section left, and that's going to go and be my H4.